Okay, so this this Bornhaber example is very similar, and you're gonna have practice with this at the end of the note packet. There's practice, but very similar, except for you can solve for two things in these problems. So you can solve for, like we did on the last problem. On the last problem, we were solving for the lattice energy. So that was this step right here. So we were solving for that step. But you can also solve for the last step, the delta heat of formation, which I think is a little easier. And so this example 12 is a little easier, in my opinion, because you're solving for, like, if it's an addition problem, um, then it's a little harder to do this, which we did a minute ago, than to do that, right? Like, so this is the one we're doing now where you just add everything up. So it's a little bit easier. Doesn't mean it's easy. I just think that mathematically a little more straightforward. So, okay. So it says calculate the heat of formation. So we learned on the last example that's the target, that's the end. And so BaCl2. So we're just going to do down at the bottom, we're going to do some normal chemistry. So that's going to be barium as a solid plus diatomic chlorine as a gas, and then that's going to be BaCl2. Okay, so when you look at that, it says that we're trying to find that, and so we're going to go delta H sub F, and this is what we're looking for. Okay, so we're actually looking for the target equation, so we're going to put a line here. And we want to remind ourselves that, hey, this is the target equation right here. So that's my target equation. And so we're going to go ahead and just kind of fill the pieces in. So the first thing says the heat of sublimation. So we learned on the last problem that sublimation was going from a solid to a gas. So we're going to go barium as a solid is going to turn into barium as a gas, and then the delta H value for that is going to be the positive 178. Now, it says the first ionization energy for barium. So that means barium as a gas turns into barium plus 1 also as a gas. And so if you want to go from 0 to plus 1, you want to tear off one of those electrons, that's going to cost 503. So the second ionization energy, same thing, except for we're already at plus 1. And now we're going to go ahead and turn it into a plus 2. And the delta H for that is positive 965. And then it says, so we took care of this one. So it says the enthalpy for changing chlorine as a gas to 2-chlorine as a gas is 239. So that is the same as dissociation energy. They just worded it different. They just said, hey, you've got chlorine diatomic. We're going to break it into 2 individual chlorines, but they could have said dissociation energy like they did on the last one. So it's very similar. 239. And probably should put the plus there. And then if we look, electron affinity, remember this is becoming negative, and it's only 1 Cl. That's a really big deal, right? So it's 1 Cl as a gas is going to turn into 1 Cl minus as a gas, and then that is negative 348. And then last, it says the lattice energy, which we kind of messed up last time. That was my fault. I didn't balance it. Lattice energy is negative 2056. So let's remember, lattice energy means we've got a gas plus a gas, and it equals a solid. And those gases have charges. So we have to make sure we have that format. The other thing that's tricky is that whatever is the product, we only get one of. So you get one BaCl2. You cannot change that. And we'll look at that here. So barium as a gas and with a charge is Ba plus 2. And then chlorine with a charge as a gas, Cl minus, turns into BaCl2 as a solid. Now, what I was saying is that the definition for lattice energy, if we go back here, the definition for lattice energy says 1 mole of your solid from the gases. Okay, that means that this has to stay a 1. You cannot change that. So that value has to stay a 1 on all these problems for this particular step, okay, for this step right here. Which means when you balance it, you have to balance it over here. And so I'm going to have to put in erase that real quick. I'm going to have to put in a 2 to satisfy those chlorines, to get those chlorines to balance. That's kind of a bad looking 2. So it's going to look like that. Okay, now, what was the delta H here? My spacing is a little bit bad, so we're going to say the delta H of the lattice equals, and it said it was negative 2056. Okay, now we just figure it out. We cancel so that we have all the stuff canceled and keep the stuff that we want. You can modify any line that you need to, but you have to make sure that you're left with this chemical and this chemical and this chemical. So let's find them. Okay, we're going to keep that barium. So we want that. So that's a keeper. So let's do some canceling. So this barium, oops, don't want the highlighter. This barium is a gas, cancels with this one. This barium plus 1 cancels here. Okay, that's good. This barium plus 2 cancels with this one. See, that's right and left. So this is right. That was left. Diatomic chlorine, we want to keep that. So that is also a keeper. And so we have found this one and this one. And then 2 chlorines. Oh, wait a minute. I need to cancel 2, but I only have 1. Same trick as last time. We're going to have to multiply this line by 2. I want to make sure you understand, though, that this is not always what you have to do. It's just in these examples, you happen to do that multiplying twice. Sometimes you have to divide things to get it to work. Sometimes you have to do more than one line. It's just in this situation, it worked out very similar on both examples. So now this will cancel. We've got 2 chlorine minuses here on the right and here on the left. And then the last thing, we want to keep this because it goes there with a BaCl. Boom. That should be everything. So now mathematically, you're just going to add this plus this plus this plus this plus this plus this to get your delta Heta formation. Now, make sure that you pay attention to your negative sign. So I've got my calculator out. I'm not going to write this out because I think you guys can understand what's going on here. So we're going to go 178 plus 503, enter. And I do hit enter after each step just to make sure that the calculator doesn't get confused somehow. Plus 965 plus 239, hit enter, plus in parentheses negative 348 times 2, close parentheses, hit enter, plus negative 2056, and hit enter. Now, if you do all that, you should get an answer of negative 867. And I'll put that here, negative 867. So that is the final answer. And this one is quite a bit easier because of the ability to just sort of add it all up. So, okay, so you got an example for both of the things that you would find. You would only be asked to find either this value or this value. So on this example, 12, we found delta H sub F. On this example here, 11, there we go. We found the lattice energy. So you have an example for both. You should expect this on the test, of course. One of the two, probably not both because they take a while. And I will say that this is another place where it is important to do good bookkeeping. If you are not doing good bookkeeping, if you're trying to do this in your head, you will often make a mistake. I make them all the time, and I try to show as much work as possible. So, all right.